Hello everyone. In my second video on Simulink Stateflow, I'm going to show you several new topics. If you looked at my previous video, I talked about the charts, states, what you can do with entry actions, input from Simulink and output to Simulink inside the chart. I briefly mentioned during versus entry versus exit, but today I'm going to show you with more details. We saw transitions and providing the conditions for the transition, box, subchart, graphical functions, and I showed you that executions have priorities, but I did not talk about how to change it. So today I'm going to show you how to change the execution order. I'm going to show you practically the difference between during, entry, and exit actions using an example with a local variable. So that's another topic I'm going to provide. I'm going to show you a junction. What is a junction? How would you do it? And remember, for transitions, we only provided a condition, but we saw that you can also create actions during a transition. That's what I'm going to talk about. Some interesting commands like after, before, at, and so on. I'm going to show you Simulink and MATLAB functions. We're going to see Model, Explorer, and Symbols Pane, and changing the animation speed. So bear up with me in the second video of MATLAB Simulink Stateflow, and I'm going to show you some more advanced topics. And then in the third video, we're going to go and look at the topics we have not covered in these two. So here I have a chart demo panel, and inside this chart I have 4 states, state 1, 2, 3, and 4, where in state 1 I send the output variable LED light to be set to 0. In state 2 it is 1, in state 3 it is 2, and in state 4 it is 3. And state 4 is my default state. Okay, so I have 4 states here, and 4 can go to 3 if the switch on input to this chart is equal to 1, and you can see that that is coming from this constant, which is controlled by this toggle switch, right? So if you go here, you see it is attached to this constant. When it's on, it's 1. When it's off, it's 0. There is another input into the chart, that is this slider in, which is coming from this constant here, and this constant right now is at 0.7, but you can change it through this constant. So when you move it to the left or right, it's going to go from 0 to 1. So I have 2 inputs and I have 2 outputs. One of them is LED light, a logical variable which is attached to this LED. And this LED has 4 states, as you can see, states from 0 to 3, and for each one of them it shows a different color, right? So red, orange, blue, and green, and if it's undefined for any reason, it goes gray. Also, which one of these states the system is at, state 1, 2, 3, 4, I'm going to send out this double variable system state and show it on this display. So 2 inputs and 2 outputs. And I showed you why I need a toggle switch, a slider, and a lamp. I'll talk about this real-time sync later. But you see here, if the switch is on, I start with default state 4. If switch is on, I'm going to transition to state 3. Then here is the new command that I mentioned, after 3 seconds. So sometimes when you want to do transition, you're not always looking at some variable equal to or bigger than or less than something. Sometimes you might need time. Some operation has to be done after so many seconds or so many minutes. Can I do that? Yes. Do I need to bring the time as an input to my Simulink block? No. I can just use this command after and then say 3, second. That's all you need. So this transition will automatically happen after what? 3 seconds, regardless of the inputs or outputs. Then you see that I'm not directly coming to any other state here. I'm going to a junction, and this is the junction. So I go to a junction, and then based on some other conditions, I decide whether I should transition to state 1 or transition to state 2. Okay, so when you want to have branches of decisions of a major one, right, you want to create sub-branches, right, or branches or sub-branches, you need to have what? You need to have a junction. That's the application of a junction. So here I say, if the scale 2 of slider in is bigger than 15, do this transition. If a scale 1 of slider in is less than or equal to 15, then do this one. So slider in, remember, is the number that you read from the slider, which is between 0 and 1. Now, I'm not going to use that slider in directly. I'm going to pass them to some functions. Those functions called scaled 1 and scale 2, they're going to return a number to me, which is between 0 and 30, as we're going to see, and then based on that, I make a decision. So what are these two functions, scale 1 and 2? One of them is a MATLAB function, the other one is a Simulink function. Remember, in the previous video, I showed you how to apply a graphical function. Here, we're going to talk about creating a MATLAB and a Simulink function. So you see, I'm using both of them. And so I make a decision, and I either go to this or this, and then these two will go back to state 4 if what? If the switch on is 0, which means the switch is turned off. Okay, so you see inside the brackets for each transition, I have the condition that it needs to have for the transition to happen. Now, on the top of that, next to the bracket, I have a what? I have these braces, these curly braces. Inside the braces, you can define the actions here. So not only I need a condition for this transition to happen, but when it happens, I can run some commands. What command? Here I say I want system state to be 3. Why? Because I'm switching to state 3. So the output, one of the outputs of this chart, which is system state, I set it to what? To 3. When I transition to here, you see, I set my system state to 2. When I transition to 1, I set my system state to 1. And when I go to 4, then I say my system state is what? 4. Okay? Yes? So you see that here, I can provide actions inside the transitions by what? By curly braces. Okay, so far what you have seen me doing is I talked about creating a transition action using the after command, and there are other commands similar to it, which I'm going to show you. Talked about the junction, and I talked about, I assume, Simulink and MATLAB functions in general, right? Now let's go back and see a few other things. So let me run it, basically. Let me first run it. So I set this to 0. I turn it on. Okay, you see it's green because I'm in state 4. I turn on, so now it switches to that. It becomes blue. Now it goes to what? To this state, which is a state 1, and becomes red. And it stays there until I turn it off. Then it goes back to green. You see? Again, turn it on. Switches to state 3, blue. This time again goes to red and goes back on. Why does it go to red each time and not to the state 2? Because the value that I have, this scale of slider in, is bigger than 15. So if I drag this way and run it again, look what happens. So now it should go to orange. There we go. You see? Now jump to state 2 and stays there. And I can turn it off and it goes back to state 4. So it either goes to 1 or 2 depending on the location of this slider. If it's to the left side of the middle point, it goes to the state 2. If it's to the right side of the middle point, it goes to what? To 1. Look here. And you see this transition automatically happens after 3 seconds. It jumped from here to here, right? It did not wait for me to turn anything on or off. This transition here automatically happens after 3 seconds. Okay, that's the beautiful part of it. Look, 3, done. Okay, so now you might say, what is this guy? This one, this block, I showed you in my previous videos. This is called real-time sync, and this makes the time of the simulation to match the time of the clock. Because if you don't have this, look what happens. If I take this off, right, and run it again, let me turn this on here. Did you see how fast it went from this blue to red? Let's do it again. Look. You see? It was clearly not 3 seconds. It should take 3 seconds for this transition and then go from junction to one of those. But you clearly look again, it's definitely not 3 seconds. Look, here, it's just like a fraction of a second. Because my simulation is running much faster than the actual clock, 1 second, 2 seconds. But if I bring this guy here, if I bring this block, then the simulation time tries to be synchronized with the actual clock time. Look here. Now, when it goes to this state and want to go to junction, you see really it takes 3 seconds or so. Here, look. 1, 2, 3. There we go. See, maybe I counted a little bit fast, 1, 2, 3, but it's clearly 3 seconds. 1, 2, 3. Here. You see, so it's clearly what? It's clearly doing its job. Now, another thing you have, which you can control the speed a little bit, is called animation speed, and that is under the debug tab. If you go to debug tab, you see here it says animation speed. There is none here, but if I make it slow, hopefully it's not as fast as last time. That transition between state 3 and either 2 or 1 was very fast. So let's run it again, see when I put it on slow, whether it does a slower job here. There we go. You see, that was a little bit better. It was not as fast as when I didn't have it. You see, it took about a second or so, or a little bit more than a second. But if I put this on fast, look what happens. You see? Almost as soon as it came here, immediately transition to next one. Okay, and then I can put it, of course, on medium and so on. So although you can control a little bit the execution speed or the animation speed, but still, even the slow version of that might not exactly be synchronous with the clock on your computer. So if you want that, instead of changing the animation speed here, because that clearly depends on how much computation you are doing. So sometimes the slow of that might be even slower than your clock. Here is faster because I'm doing some very basic things. If you want it to really be synchronous, my recommendation is what? Is to bring that sync block here and real-time sync, and this one will make the animation a lot more reasonable to what we expect. Okay, now let's look at several things. First, what is the MATLAB function? What is the Simulink function? So this is the MATLAB function. You just grab it, drop it here, and then you double click, and here you can provide the code for a MATLAB. So you can say function y equals my function of x, and let's say y equals x squared or something, right? And if you go back, you see it's there, and this function does not need any input port or output port. As soon as you call it and pass it some input, it should give you the output. You see here, look at this scale 1. So I pass to it the value for slider in, and it gives me the output of that. Now, what is the output of that? As you can see here, it is what? It is basically 20 times input plus 10. So since input is between 0 to 1, the output is going to be between 10 to 30, right? So clearly you can see that, and I put my decision point at 15, but you can put it anywhere as long as it's between 10 to 30. Okay, and a similar thing can be done with the Simulink function. So this is Simulink, this one. This is the Simulink function. You bring it and you double click on it, and here you're not going to touch that. That's just a block showing you have a function. Don't change that. You can change the name of it, but don't remove it or anything. So just give it whatever you want. Again, you can call it my fun, right? And here you need to have, this is like a subsystem in Simulink. You need to bring in some input, put some operation on the input, and get the output, right? So you need to go back to Simulink And under Simulink commonly used blocks, you need an input, need an output block, and then between this input and output, you can do whatever you want, right? So you can, let's say, bring in a gain like that, and here can call it whatever, maybe this one Y, this one X, and bring this X to a gain and multiply it by something, right, and make it like 3 or so. Here, that's all it does is make it 3 times, but you can make the Simulink as complicated as you want, okay? So that is how you create a what? You create a Simulink function, right? So this is for creating the Simulink function and MATLAB function. Now, the next thing we need to talk about is, and you see that we have used them, the next thing we have to talk about is the priority order. So if you see here in the junction, there is a 1 and there is a 2 next to these transitions, and that means the first one is checked first, and it's going to go first if the condition is true. And if that one doesn't, then this one does. So if you compare it against if else, this is like your top if, and this is like your else. Or if you have 3 branches, 1 is like if, 2 is like else if, and 3 is like the final else, okay? So the execution order here is 1 is this guy, 2 is this one. But if you want to change the order, so you want the top transition to be 2 and the bottom one here be 1, you can change that if you want. How? So here, if I click on this 2, right, and right click here, let's see, and go to execution order, you see the execution of this guy is 2, I can change it to 1. Look, there we go. So now this is going to be the first one to be checked. This is going to be the second one to be checked. Okay? Yeah, you see? You can do that. And here, by the way, when you click on a transition line, if you want, you can add a breakpoint anywhere along the transition as well. So you don't need to always grab a transition from here and drop it somewhere, right? Anywhere along these transitions, you want to make a branch or something, you can just click here and then go there and what? Add a what? Add a break. Okay, so let's talk about the rest of it. So I assume I covered these 2 for you, right? I also covered, let me change the color. I added this, I added this, and this. So remember I showed you the after, and after was this transition will happen after 3 seconds. Is there any other command like that which can be useful? Yes, if you look at MATLAB help, you can see there are other commands. Let me see if I can find them for you. Where is that? Here. So if you look here, there is the command after. So you can do after so many seconds and some event, or here in just, you can use SEC for second, right? Or you can do after so many ticks or something. But there are other commands similar to it. So there is one that is before. You can do something before so much time or some event. You can do at. There is every, and there is timer. If I have time, I'm going to show how to use each and every one of them, but like the command before acts similar. So if I say change it before 3 seconds, right, or before something happens, then it does that. And again, it doesn't need to be specifically so much of time. You can have event E. So it happens before that event E is happening, or after that, or at. It can happen at exactly so much time, or at some event. Now, what is event? I'll cover that in my next video, okay? I cover messages and events in the next video. But here, I just want to show you there are these powerful commands, before, after, at, every. Okay, you see here? It said every N and E returns true at every nth occurrence of the event E. Okay, so if you say 2 and some event, every other times the event is happening, it returns a true. So you can have every 10 times the event is happening, you return a true for me. And then you have the timer, which is a powerful command. It returns the time for you if you want. Okay, it creates an object, and then you can have the get command to give you time, or you can have the set command to set up the time. Okay, and as I said, I'll try to cover them in my next video, but just want to tell you that not only we have the after command, we can have before, at, every, and time, and they are powerful commands. So here my goal is to just refer to these guys, not really completely cover them. Okay, the next thing I promised to talk about, since in previous video I briefly mentioned during versus entry versus exit, I want to demonstrate them to you. And I want to do that using a local variable. Remember here, these variables switch on and slide in. They are variables outside the chart that can be brought in from Simulink, and LED and system state are the variables that it communicates outside the chart. But there are some variables that you can have just inside the chart, and no communication happens between those variables and what? And the rest of the Simulink. We call them a local variable, or you can create a constant or parameter. How do we do those? Here, this variable called var, V-A-R, that is one of them. How would you make them? You right click here and go to, you see here, these are input outputs. You can have input and output from Simulink. You can have event and messages, which we'll cover later. If you go under add other elements, you can create a parameter, a local data, a constant, or anything. You can create local event, local message. So here, if I want to say I want a local what? I want a local data. And it says what? Here you give it a name. I called the previous one var. And if I want to see how this var is changing versus time, I want to monitor it later, right? Not only I can change the scope of it, right? You see here, the scope of it is local. I'm not going to make it input or output so I can communicate to outside Simulink. I just keep it local. And the type of it, I can say inherit, or I can provide any type I want. I can provide the size, anything. The other thing, if you want to see what happens to it, you can go to logging and turn this one on, log signal data. Then you can look at the history of this guy. And this is exactly what I did here with this variable var. So I created the local variable var, and I made sure that it can what? It can be logged, okay? So now inside this state, I'm changing var, or I can do it even during my transitions, but I do it with different kind of functions, or different kind of type of decision making. Like the first one, I did it with entry. So as soon as you enter state 4, this variable will be set to 1. Regardless of what happened in the past, as soon as your system transitions into state 4, my variable var becomes 1. Then as soon as what? You enter state 3, LED light becomes 2, but the var does not change until you exit state 3. When you exit state 3, which happens after 3 seconds, then automatically var becomes what? 3. And then what? When you come to state 1, during being in state 1, you keep adding 1 to what? To this variable. So during all of the times, sample times, this guy, this var is going to be increasing by 1 during each and every one of those sample times. And if you go to state 2, nothing is going to happen to variable. Okay? So now here I'm going to run my Simulink, different versions, different times. So first, remember the bottom transition happens when this number is less than the midpoint. So here I had it above midpoint, so it comes from 4 to 3 and then it goes to 1. And while we are at 1, it keeps increasing by 1 until I turn the switch off, then it goes back to 1. Right? So what I expected I should start at 1, then I should go to 3 when I turn the switch on. Then after 3 seconds, it should switch to what? To here when it is incremented 1 at a time at each sample until I turn the switch off again, then it goes back to 1, right? So let's go and take a look here. So I run it. Here, it became 1, now it's 3. Now here, you see, at the while we are in state 1, it just keep increasing by 1. So now it should have gone quite a bit higher. And now I turn it off, and now it should have gone back to 1 again. And now I'm gonna pause the simulation. And if you want to see what happened to this variable that you logged, you can what? You can click on this guy here called Data Inspector. So click on Data Inspector, and this should show you the history of whatever that you logged. So if you go here under Stateflow, you can see a state 4 that I logged, as well as what? Variable. And if I double click on variable here, look here, let me show you. Look. So let's say I don't want state 4, just variable 1. You see, when I switched to 1, I became what? The variable became 1, right? At the beginning. Then what? Then it stayed at 1 until what? Until 3 seconds. And you might say, this is 3.1. Yes, because you did after 3 seconds switch to the other state. So the next sample point that the time is bigger than 3, it switched from 1 to what? From 1 to 3. Here, this jump is from 1 to 3, you can see. So since you said after, if you said at 3, then this stepping would happen right here. And if you said before 3, do the step, then it would do it at 2.9. Because it seems like your sample time here is about 0.1 second. Okay, so and it is using a fixed sample time here, a fixed step size. So write the step size, the sample time right after 3. It switched from 1 to 3, and now look, here is when you go to the state 1 and you keep incrementing 1 at a time at each sample point until I turn the switch off here. And then from this value, which is 142 or something, all of a sudden what? Drops right back to 1 here. You see? Because it went back to state 1, to state 4. Okay? So it clearly shows you the difference between entry, exit, and during. This simple jump here is entry. This one here is exit, which acts similar to entry, but after you get out of the state. And here is during, which happens as long as you are in the state. Okay? Yeah? So it took all the time until I went and I basically turned the switch back to off, so it can go to state 4 and drops back to 1. Yeah. Now if I this time bring my slider here, so it goes from here to here, in state 2 there is no command for changing variable. So if it goes from 1 to 3, when I switch to 2, the variable should not be increasing at all until I turn it off and it goes back to 1. Look here. Let me stop this and I run it again. There we go. Let's do it again. Jump to 1, jump to 3. Now it should go to 2. In 2, nothing happens to variable. And now what? If I switch it back, it should jump back to 1. So again, we're going to pause it and we're going to look at the inspector data. Data inspector, I'm sorry. Let's take a look. There we go. You see? Look at it. So it jumped from 0 to 1, then it went for 3 seconds, then it went what? up to 3, and then stayed at 3 in state 2 until I turned the switch off, then it went back to 1. Yeah? So if I wanted, I could do a during, and I could do a decrement in state 2, right? So here I could add and say, hey, during being in state 2, var equals var minus 1. Then you would see the decrement. And here, instead of after, I could have made this what? I could have made it at. Then you will see the switch is happening exactly at 3 seconds and not at 3.1. So these are all of the things that you have under your control, right? And you can make your logic as complicated as you want. So now clearly I'm gonna have a much different behavior this time, right? If I run it one more time, you're gonna see quite a bit different behavior. Okay, the only thing is if it gives you, you see here it says at and every as absolute term is supported only in standalone charts. Your chart is not a standalone, so that is very good to know that if you do at, your chart should be standalone. Your chart here takes the data from input and sends to output. It's not completely standalone. Okay, so if you ever use at and every, be careful that your chart is a standalone. But here I could have used before. Before and after should work, no worries, but clearly what? Not at. So here I did the before, it goes there again, stays there, and go back. Stop the simulation and look at data inspector, and I should get a different behavior this time. There we go. And you can clearly see that the behavior is different. Okay, so I guess I explained these two for you. Now, the last thing I want to talk about is Model Explorer and Symbols Pane. So here, if you want to see what symbols, what variables you have, you want to take a look at them. If you go under Modeling, you have here Symbols Pane, and if you click on it, it shows you exactly the type of variables you have and the type of functions. So you have a scale 1, which has input and output. You have a scale 2, which is your Simulink one, and you have system state, slider in, LED light, switch on, and variable. And it shows to which ports they are connected, and you see on the inputs they have arrow on the left side of the chart. The outputs, they have arrow on the right side of the chart, and the local variables, they have no arrow, means they are local to the chart. Okay, so that is the Symbols Pane, and the other one is this guy here, Model Explorer, which can provide you some interesting information as well here. So you see, if you go here under Stateflow Demo 2, which is the total file, you can set the configurations, you can look at the model workspace if there is anything, you can look at if there is any external data, which I don't have, and go under Demo Panel. Now under Demo Panel, you see that I have basically these variables. It shows what kind of variable they are, their type, their size, right, and anything. So it's basically like a workspace for your data here, right? And you can click on each and every one of them, and you should be able to change something. So like here you see state 4 is that, entry function is this and this one, and if you can change, if you want, you can change them, and you can create output for monitoring if you want, right? You see self activity and so on and so forth, right? And then you can apply that. Okay, so you're able, if you want to change the login here, you can do that, right? So you see here I turn off the logging for state 4, right? And I can apply that. And if you look at the state 4 here versus the other state, you see right next to state 4 there is this kind of like Wi-Fi symbol, right? So that means this state 4 will communicate its data and how it is to what? To the logging of the Simulink, while the other ones are not being logged. Okay, so you can put that there, and as we just saw, when you go to the data inspector, Now, not only we had this local variable var, we also had what? We also had state 4, remember here, right? And if I want, I can monitor state 4. And it shows me what? It shows me how state 4 was on and off. So you see here, it was on for a little bit over 3 seconds, then it became off, and then it turned on again, and so on. So you can look at the history of each and every one of the states by logging it, okay? And there are a lot more here. There is sequence viewer, there is logic analyzer, and so on. But I would rather, and if you want to see events, there is log event. There are lots of logs here, okay? And as time allows me in my future videos, I'm gonna over them. But most of the things you want are most of them are either modeling, most of the things that you have, okay? And most of the blocks, most of the things that you want, they are here. And you see here, I have property inspector and so many other things. And you see here, local data add parameter. So everything that you could have right click and basically create, right? Most of them, they have a button here as well on the top. So this is the second video, and I covered some material for you here. And in my next video, I go over more advanced topics and show you how to work with those. I'm going to give you, and look at here, one last thing, I just found it. I just paid attention to it. Remember this state 4, you see here, I can directly send it out to, right? Remember when I did click and I said log self activity, right? Because if I go back, yeah, I need to explain this one more time. Look, when we looked at the state 4, I created an output. That's different than logging. If you just want to see it in the data inspector, all you need is to do log self activity. But if you want to create an output port for it in the chart, you check this guy. So now you have what? Now you have an output for state 4, okay? A separate state 4. If you don't like it, feel free to what? Just simply turn this one off. And if you apply that, that port is gone now, as you can see. Okay, so each state, you can literally send it out directly, as I showed you, and maybe export it to MATLAB, and also what? You can also plot anything about it in MATLAB if you want, not just Simulink. So hopefully this video was useful to you. I'll give you a download link for this demo panel so you can play with it and learn from it, and I'll see you in the next lecture. Thank you so much.